So we're going to have to start this one again, so just let me catch up to where we left off yesterday as we go through it. So we're starting out with x plus 3 over x minus 2. We're going to bring the 4 to the left-hand side, so it's coming over as negative 4, so that it's compared to 0. We talked yesterday about we want to add them or combine them, so we're going to have to get a common denominator, and some of you may think of this as 4 over 1. So instead of multiplying everything by x minus 2, we're going to get x minus 2 over x minus 2, sneaky form of 1. So I did not change this. This is still x plus 3 over x minus 2. Now at the negative sign, you have to be careful. You either use it now or you use it later. Let's just go ahead and take negative 4. This might be a little bit different than what we did yesterday, but negative 4 times x gives me negative 4x. Negative 4 times negative 8 gives me positive 8 all over x minus 2. Because I took the negative sign, we're just adding them together now. So you do that work to get the common denominator. So what we're looking at, what's x minus 4x? Negative 3x. And what's 3 plus 8? All over x minus 2 compared to 0. So we got to that point where we had the rational expression. We talked about what makes it 0 and what's the critical point. So one time you're going to do x minus 2 is equal to 0. So you're taking the stuff on the bottom. When is that 0? Because you can't do division by 0. So if the bottom is 0, it doesn't work. So that's critical because it makes the bottom 0. So 2 is a critical value. You also take the stuff on top.
You said 0 last time.
We had 0 and 11.
We also have to find when the top is 0, because remember what we talked about yesterday. If the top is 0 and the bottom is some number, that's equal to 0. So you subtract 11. Divide by negative 3. So the red number is critical because it makes something that's undefined, division by 0. 11/3 is critical because it actually makes this expression equal to 0. So with those two values, you put them on a number line. Let's put it right here. So 2 goes here. 11/3 is almost 4, so that would be over here. What goes above the 2 and the 11/3? 11/3 gets a closed dot, and 2 gets a open dot. Now this is a greater than or equal to problem, and a lot of times we want to put closed dots in there. But remember, why is 2 critical? Can you use 2? So even though it's a greater than or equal to problem, if you try to use 2, calculator is airing out, it's undefined, right? So you cannot use 2 in this problem. Cannot use it. So it gets an open dot. So there are the 2 critical values on the graph or the number line. So my first interval is negative infinity up to 2, parentheses around both of those. And if you're careful when you do your intervals, at the very end of the problem, all you do is rewrite them. So 2 to 11/3. Now watch your parentheses here, square bracket over there. 11/3 to infinity. So infinities never get the brackets, right? Give me a value between negative infinity and 2 that you can do in your head. 1, negative 10, all that stuff. But 0 is the easiest right now. So, plug in 0. I would go with your x values. We're going right there. So when you put in 0 for the x and 0 for the x, you're left with 11 over negative 2. I really don't care what the number is. What happens when you take a positive and you divide by negative? Negative. What are we looking for? Things that are greater than 0 will have a positive sign on them. So we're looking for positive. Something between 2 and 11 thirds.
3.
3. That's the only whole number there. So this is negative 9 plus 11, which would be a positive 2. And then on the bottom, I have a positive 1. So by plugging in 3 into that purple factored form. So positive divided by positive is positive. And finally, 11 thirds to infinity, probably 10, which is negative 30 plus 11 will be a negative. And 10 minus 2 is a positive. And what happens when you take a negative divided by a positive? You get negative. And so, because this is positive here, this right there is my solution. To 11 thirds works.